Now, joining us for a discussion on fastest capacity, scaling the grid for energy dominance in the next 2 years. Please welcome Energy Market Development at Google, Kaitlin Savage, President at MacLean Power Systems, Michael Plaster, Chief Executive Officer and Chief Technology Officer at NewGrid Inc., Dr. Pablo Ruiz. Moderated by President and Chief Executive Officer of the National Electrical Manufacturers Association, Debra Phillips.
Okay, good afternoon, everyone. Hopefully you're energized here after lunch, and our distinguished panel is going to keep bringing that energy through the next 45 minutes of discussion. We're here to talk about how to scale generation and electricity supply in the fastest time frames. I know throughout the proceedings thus far, there's been a lot of conversations about what's coming in terms of demand for electricity. I represent the electrical equipment suppliers, NEMA, and we too have an outlook that projects that by 2050, we will see a 55% increase in demand from electricity, largely driven by data centers in the short term, but by electrification of industry, buildings, homes, offices, medical care, transportation systems, you name it, it's all converging and gonna lead us down a path of having to be creative to fill this gap between today's supply and that future demand. So we're here to talk to some experts about what they see from their vantage point. We have Kaitlin from Google, Pablo from NewGrid, Mike from MacLean Power Solutions. So we're gonna start by talking a little bit about what's available today. What experiences have you had with deployment of technologies that are going to help us bridge this gap? So Kaitlin, let's start with you.
Hey, great to be here. Kaitlin Savage. I work on energy market development for Google, leading a lot of our work on transmission. One of the things that we're doing at Google is a new partnership with a US company called CTC Global. They manufacture advanced conductors. So when you look at power lines today, many of those lines are running on technology patented over a century ago. What CTC Global does is they manufacture these advanced carbon core conductors. They don't sag as much when they get hot, so you can push more power through them. And what we've realized at Google is that customers and corporate buyers historically haven't really engaged in accelerating deployment of those advanced transmission technologies. So from our point of view, being able to swap out wires is really a speed to power solution. You can essentially double the transmission transfer capacity within an existing corridor in a matter of months instead of potentially 10 plus years for new greenfield lines. So it's really not an either or, it's an and approach in parallel as we're building out some of these larger infrastructure projects. And not just a speed to power solution, but at Google we focus a lot on our grid citizenship initiatives, and it's a really incredible demonstration of that. These technologies, because you don't need to acquire a new right-of-way if you're reconductoring an existing line, you save a lot of money on land acquisition, permitting, you don't necessarily need to do if you're in a brownfield. And then just the potential ratepayer savings associated with deferred capital investments, congestion savings, all these sorts of things that sort of flow from that. And in places where we're seeing generation, the interconnection costs have gone up significantly in the last few years. So by doing some of these proactive transmission upgrades, we can also put downward pressure on corporate PPAs, just for example. So we're partnering with CTC Global the same way we pay a carbon-free energy premium on generation. We're offering essentially to pay a premium on transmission to accelerate deployment of these technologies. We're offering that financial assistance. We're doing some workforce development on lineman training. We'll have some more details to announce soon. And then we're also providing technical assistance. We've realized a lot of utilities struggle to study integration of these technologies on their system. So we're paying for either consultants or in-house studies to evaluate applications of the technology. So that's one of the things that I'm very excited about. We've learned a lot of lessons since that partnership was announced in June. I'm excited to talk more about what those lessons are.
Okay, great. We can't wait to hear more. It's really sort of groundbreaking, that kind of initiative and deployment, just from a timing standpoint. What are you seeing in terms of time to market by pursuing reconductoring?
Yeah, I mean, CTC has an incredible number of case studies where they're actually coming in much faster than they originally anticipated, which is somewhat unheard of, I think, in many of these transmission build-outs.
Good problem.
But they have some examples in Europe of them, swapping wires in as little as 6 months, doing live installations to sort of bypass outage requirements, which add a lot of time to new transmission builds. And in theory, we could be upgrading the system and potentially adding gigawatts in a matter of less than 24 months, which when you look at all the other options available from Greenfield is pretty unheard of.
Yeah, amazing acceleration. Okay, so let's move to Pablo. Pablo, your company has solutions that are sometimes described as a navigation system for the grid in terms of a digital solution. So maybe you can talk a little bit more about that.
Yeah, absolutely. We are very much a software solution. We say that we are the Google Maps for the grid, or the GPS app for the grid, in the sense that when you're driving and face congestion, most likely you will pull up your favorite GPS app and see, are there alternative routes that I can take and save time and get the instructions for how to do how to take that route, which would be different from your usual. So along the same lines, our technology, which was developed with ARPA-E funding, so U.S. government funding a number of years ago, find ways to reroute flow over the existing network. And where the rerouting is achieved by reconfigurations of the grid. The grid has thousands and tens of thousands of circuit breakers for protection reasons, for operational reasons. What our technology does is it finds the breakers that, if open or if closed, would reroute flow. We're usually finding that you can move around critical bottlenecks in operations anywhere between 5, 10, 20, 30, 40% more flow over those specific bottlenecks when you, let's say, fine-tune the grid to those system conditions. So it's a grid-wide type of optimization approach where we are effectively taking the utility look and see how would it make sense to fine-tune the network.
Okay, and do you have practical examples of deployment of this technology and what it's achieved?
Absolutely. So we partner with transmission owners, transmission customers. One of our largest partners is Alliant Energy in the Midwest, as well as ITC. Krista Tanner was here on stage yesterday. We find that working with them, the ratepayers of Alliant save about $24 million per year in terms of reduced congestion costs, reduced curtailments, increased production. Those percolate directly to the ratepayers. That's on top of any cost protection or hedging strategies that they have.
Yep.
So it's very much an affordability type of play.
Okay, amazing. Now let's move from software to hardware. And I'll ask Mike from MacLean Power Solutions to talk a little bit about the hardware that's available to also increase supply.
Yeah, I mean, I think the first piece is MacLean Power Systems goes from transmission to distribution. So on the overhead lines that you described, we make the hardware and the insulators. So insulators from polymer, glass, and porcelain. On the reconductoring side, that hardware has to support a higher power, so it's a higher temperature. So we've gone and extended our hardware to support reconductoring, which is important. When you get into the substation, we make equipment in the substation. I call it grid essential. You can't do it without these products. So it's high voltage switches, high voltage instrument transformers. When we talk about circuit breakers, we don't make circuit breakers, but we make a controller that will basically switch the breaker at the least stressful time, so it's point-on wave control. Why is that important? These are critical assets with some of the longest lead times in the industry, and we want to extend the life. We do the same for transformers, which we don't manufacture the power transformers, but again, have this point-on wave control. When we get into the distribution grid, a really simple application really goes back to the limited workforce, or I should say the workforce and efficiency. We took an inline disconnect in the distribution side called the ergo switch, and we designed it with the input from linemen and from utilities. And so instead of having 2 linemen install this switch, it only takes 1 lineman and no special tools. So we try to partner closely with our customers to develop and extend our product range. And along the lines of transmission, our switches will now go to 500 kV, which we'll see at the IEEE show next week. and then on to 765, because it's about getting the most out of our existing infrastructure and then certainly supporting the new greenfield transmission projects and distribution projects.
Okay, so an array of technologies that are ready to go, being deployed in the field. We talked about reconductoring, digital, software solutions, hardware, grid-enhancing technology solutions. What else? What else are you aware of that's kind of out there that this audience might find interesting?
I'll be happy to jump in. So our technology is called topology optimization. It's one of a class of technologies which, as you mentioned, is called grid-enhancing technologies. It's a class of technologies that take the existing grid and try to extract as much value as possible. So other grid-enhancing technologies include dynamic land ratings systems, where it's the ability to have sensing or very, very detailed estimation of the actual capacity of the network given the existing system conditions, allowing the network to be operated closer to the true limits, which could be higher or lower than the assumed. Other technologies do something similar to what we do on the hardware side, but using on the software side, but using hardware, advanced power flow control. That's the name of the technology. So this is a class of technologies that effectively enable the grid to increase its transfer capability by north of 10%, 10, 20, 30%
Yep.
today.
Okay. Yeah, dynamic line rating. Let's add that to the list. Mike, Kaitlin, anything else that comes to mind?
I mean, I'll give another workforce example. It's very practical, but it's being used by a lot of utilities, and we call it transmission in a box. So typically, you can order all these components, and they come in separately. We actually put the insulators, the hardware, everything you need for that application labeled in it's more than a box, and that gets out to the job site. Because what happens on the job site in practical terms is material is lost or it's damaged, and the efficiency of that workforce goes way down, and then you have to reorder. So it sounds like a very simple approach, but the deployment and the adoption has been quick because it's making it much simpler when it gets to the job site and when they have to start constructing or reconductoring transmission lines.
That's very cool. I've never heard that before. I guess from our perspective, we first started looking at advanced transmission technologies about 2 years ago in earnest, and Central Ohio is a very large focus for us. We have a fairly large footprint in AEP's territory. There's a lot of commercial demand generally in that region. And it's also very important from a system architecture perspective with the 765 kV backbone there. So we had sort of zeroed in on that. There are a lot of transmission constraints and a lot of data center and growth resulting from reindustrialization in that part of the country. So we had heard a lot of feedback that stakeholders across Ohio were looking for data centers to take a more active role in developing some of these solutions. And I think one of our learnings from that is that a lot of these technologies really can't be painted with a broad brush. There are a lot of important differences as far as which type of violations they resolve and the system conditions and what level of granularity you're looking at for that specific load pocket. So we actually commissioned a study with electric power engineers to evaluate a full portfolio of technologies, and not just advanced transmission technologies, but also things like demand response, looking at certain generation projects that were sitting in the interconnection queue, that sort of thing, to see what could resolve constraints whilst awaiting some of these larger, for example, AEP Transmission is building a 250-mile greenfield transmission project. There are a lot of potential development considerations when it comes to determining a low-risk timeline for bringing those sort of projects online. So that's sort of how we landed on advanced conductors, but there were absolutely a number of different applications for other types of advanced transmission technologies. And figuring out, we sort of call it like a layer cake approach of how we put those technologies together in the right way and at the right speed, so it's not overly convoluted for the utility. They feel comfortable with the pace of adoption, but also being distinct in which technologies work where, and sort of figuring that out, because it is a lot more complex, I think, than we initially realized.
Yeah, I mean, I think that's one of the things coming out here, right? There's a whole menu of solutions, right? And it's choosing from that menu to a specific application to get the highest return. So reconductoring, GETS, dynamic line rating, digital tools, demand response, behind the meter. We didn't really talk about behind the meter, but there's behind the meter solutions as well, right? That can scale and go fast. So Now let's turn to sort of the flip side. These technologies are available. They can be deployed. You can, select wisely per whatever your application is. But what are the barriers as you see it today? Why has some of this technology not moved more quickly, been scaled across our system to, kind of do more with the grid we have today and, be more efficient, do more with less? So what's preventing us from moving forward faster?
Yeah,
Who wants to start?
I'll pipe in just because I've been in this industry a long time. And I think when you look at adoption rates, it comes down to necessity and economics and proven technology. And it's good that there's, I would say, a risk profile for utilities that is pretty conservative. It's good because we have safe, reliable power, and I think we take that for granted. So as we look at adoption rates, I think if we think of the economics of it, the description that you had on the Google side, that takes some of the economics out and it gets the adoption rate even higher. I think the other piece to this, so you talk about the conservative, I would say the great piece about the utility industry is once it's proven, they share openly. It's not like it's my IP and I won't tell you about it. Years ago, we introduced a new product, and once it was proven by one utility, it was adopted very quickly. So I think those are the drivers on why things don't go quickly, because it's a risk profile. But if they can get collaboration and co-investment, and then I would say accelerate the piloting phase, the adoption rate can get accelerated. And then necessity will always push things along.
One of the things that I think another learning we've had since last year, CTC Global, so American manufacturer of the carbon core, American developed technology, invented here in the US, 120,000 miles of it deployed, I guess almost 2 decades ago, but primarily being deployed in countries outside the US. I think their current metrics are something like over 90% of their deployments of that 120,000 miles are internationally in countries like China, across Europe, India, Bangladesh, parts of Africa. In fact, we had a meeting in Ohio maybe last year, and I heard one of their supply chain partners saying like, oh, we're working on this for Brazil and Nigeria. Companies like AAP are headquartered in Ohio, and AAP Ohio is not currently using this technology. And another great example, like AAP Texas has experience with the technology, but AAP Ohio doesn't. AAP Texas has, I think, over 15 years of experience with CTC Global technology. So I think it's a very complicated issue, but there are some of these barriers in some ways we like to say like the technology is there, at least for this specific advanced conductor application. The money is there. Companies like Google are actively asking to pay for the technology to be deployed, but there's like almost a human problem that's a lot more challenging, I think, to address. And that's sort of where we're focused on now, is getting to how we can create the right incentives and the right opportunities, and really a sense of urgency to get things done sort of outside the business as usual approach.
Yeah. Pablo, I think you've talked a little when we were having a discussion prior to this panel about the culture, sort of overcoming the cultural hurdle. You want to say more about that?
Yeah, absolutely. So the human aspects are very important, especially for us that have a technology that is a decision support tool for operators, for engineers. They are the ultimate users. So using it at scale effectively implies a change in behavior, a change in philosophy, whereas the typical approach is to assume that the grid is static, or don't touch it unless you need to. Changing that paradigm to adjust the grid all the time to extract the most value, and so that change in behavior, of course, takes time. In addition, because there are protocols, there are standards, there's a need to develop those internally by each company. That adds to the time. And I think the final aspect, and I agree with both with Kaitlin and Michael with their comments. The final thing that I would say on at least as we see it on the transmission operations side, is that there's a false perception that there's a dichotomy between the safe and reliable power and an efficient use of the grid we have. And sometimes this is for historical reasons, but the two go hand in hand. You can't you can't operate unreliably and efficient power system. That would not be so, and vice versa. So by best using the grid we have, we are also achieving the most reliable power system. So changing that mind frame into let's do the most we can with the network we have.
Yep.
Will help us move the needle.
Yeah, and moving into that mentality of we've got a dynamic system, we've got dynamic technologies, and deploying them in a more real-time way to meet load demand. So let's talk about solutions. So we've covered the technologies are out there. There's barriers, but from your vantage point, what do you see as accelerators, enablers, incentives to move forward faster? Who wants to start? Pablo, you want to kick us off?
Sure. So starting from my last comment, I think if there was a very clear signal from the regulators, from Congress on, it is a priority for the country to make the best use of the network. That will help, and it has to be very, very explicit. I think we have clearly the signals are there today. They were also with the prior administration, but and they are intensifying clearly. But I think being very direct in that messaging to the utilities, such that there's no excuse. We should do this. Which that comes short from a technology mandate, which is not what I'm advocating, but it's a mandate of let's be best stewards of the grid that the country has paid for. The ratepayers are on the hook for, and extract every dollar, every megawatt that we can out of it. There are many companies that see it that way, but I would say the industry at large doesn't.
Okay. So we need policymakers to send the clear signal. I think some of those are being sent, right? The White House is talking quite a bit about it. They've gathered hyperscalers, and commitments have been made to underwrite costs for some of this technology. There's some pieces of legislation like the Rewire Act, a bipartisan bill, McCormick and Welch, around that incentivizes investments in grid-enhancing technologies, including reconductoring. So there's some signals being sent, but maybe not. Maybe it's not enough, and it hasn't reached the volume.
Keep piling up.
Yep. Okay. Kaitlin, Mike, what do you think?
I think one of the things that people forget sometimes is that we don't control the grid, as we're also a customer. So anything we could, and we have identified upgrades on the system. But there is, to some extent, like a permission layer, and something we're also facing a lot is information asymmetry. So we gave testimony in the Ohio House Energy Committee last month that talks a little bit more specifically about some of the challenges we're facing, but essentially we don't have eyes on where there might be the best upgrades in the system. So we might be willing to spend additional capital in a given market, not just the data center investment itself, which obviously comes with a host of economic development and workforce opportunities, but also investments into the grid that, to all of these points, could potentially lower costs further and provide those reliability benefits as well as speed to power, not just for Google, but I mentioned places like Ohio. We're seeing companies like Anduril, Crum. They're also very large energy users that would benefit from additional headroom on the system, and we're really part of this broader movement around reindustrialization. And those companies are also enabled by AI and also depend on data centers to a large extent, as well as like companies like Hadrian or others who are doing sort of shipbuilding and AI like Volstead. So I think that transparency piece is really important. And essentially, I think another part of that is making sure that regulators have the right tools. I think there's 17 or 18 states in the last few years that have passed legislation around advanced transmission technologies. But as those pieces of legislation start to be enacted, what we're realizing is no one really has a full suite of tools, no individual, to fully evaluate the technology. So we're seeing studies come back, say, oh, there's no application, and we're digging into the methodology, and there's some shortcomings there. Maybe the modeling software was not compatible with what they should have been looking at, or maybe they weren't looking at congestion savings from the right perspective, all those sorts of things. So making sure that that regulators have the right tools to study application of the technology, to make sure customers have the right tools to sort of unleash those opportunities for private capital. I mean, there are arguments that future data center build-out and existing data center build-out could dwarf investments in the national highway system or railroad build-out, space race, all these sorts of things. And I think it's important for us as a company to ensure when those Google data centers are coming to your community that we're strengthening the grid. Our objective is to lower energy costs, improve reliability, but we need to make sure that the door is open for that money to flow into these upgrades in a way that pushes the system forward and serves as a catalyst, really. In the same way we've catalyzed the renewable energy industry, can we catalyze these technologies to spur their adoption in a way that might otherwise have taken 50, 100 years? We can now do in this shorter time frame because the opportunity that exists, but this whole theme around speed to power is really foundational to that.
Yep.
I look at it, and I completely agree. I think if you look at the whole supply chain, we have to look at where the constraints are. So it can be new technology and will be new technology, but we're going to pull a bunch of levers. We also have to make sure the equipment is available, because we can get the new technology, but if we can't get a power transformer, it's still going to take 3 years. So we have to make sure the investment is there on the equipment side. And then I think if you look at I'd say the whole process, you look at permitting. How do we accelerate permitting and interconnects without jeopardizing the reason why permitting and interconnects have that process? And I'm certain, looking at it, we can do the acceleration, but there are so many different levers that can slow down the investment, because we can get the adoption of technology, but if we can't get the historical equipment that can't be replaced by technology, it's still going to take 2 to 3 years because the equipment isn't available.
That's such a good point, because even when we do these studies, sometimes we might see, oh, we can dramatically increase the ampacity of this line, but there's a downstream violation of that, and the wait time might be 5, 6, 7 years. And in that case, I mean, hardware is another example that we talk about in our Ohio testimony, where it might be there's only one domestic manufacturer and there's a Buy USA, which I'm not saying to remove those provisions, but we need to improve the domestic supply chain and invest in that. And I think that will help, sort of resolve and provide speed to power for these downstream effects that aren't really top of mind for people.
Yeah, and the example I'd give is not on the transmission side, it's actually on the distribution side. Distribution transformers were very constrained, we'll say a few years ago, 3-year lead time on a distribution transformer that used to be, call it 20 weeks. The industry responded, they built capacity, we don't have that issue anymore, and I know the US government was involved in making sure the focus was there. I know NEMA was involved. We now have to do that across, I would say, the whole ecosystem to ensure we don't have a pinch point we didn't anticipate.
Is a perfect segue to a conversation about supply chains. These grid-related power infrastructure supply chains are complex. They have very, very deep roots. I think a lot has, COVID opened everybody's eyes about supply chains and the value of regionalization and localization. And for sure, the electrical industry has responded and reduced dependency on long chains, and especially chains with origins in Asia. But maybe talk a little bit more about what needs to be. There's still work to be done. There's critical nodes that are constrained, whether it's large power transformers, maybe it's switchgear, maybe it's a gas turbine. We've heard quite a lot about that. Electrical steel, there's not a lot of electrical steel capacity, especially grain-oriented in this country. Critical minerals, we're talking a whole lot about critical minerals, including copper. So what's the secret sauce for figuring out these supply chain issues more rationally? Is it work that we need to do as a sector? Is it signals from government, like the government stepped in for distribution transformers? There was action last week, Defense Production Act, DPA action specific to grid and the electrical supply chain. So talk a little bit about how you see us addressing these supply chain constraints.
I'll give an example, and it, again, pretty simple, but if you look at porcelain insulators in North America, there's really no manufacturers in North America. There's one, and it's small. And so those are sourced overseas. And quite frankly, the bulk, not all, but a lot come from India, and now there's a war in the Middle East, and that is causing concern on the supply. So the question becomes, and from our company, we've looked at how do we regionalize that, because 95% of our production is in North America, most in the US, but the porcelain piece of our profile is not. So we're looking at how do we do this closer to home. We'd love to do it in the US. The economics don't play out. It takes a long time because there's capital, and it's a capital intense production. So we will probably do something in the Americas, but it would be great to do it in the US. We just can't make it work economically. So how do you get over that hurdle? You've got to make sure that you know, the incentives are there, because I would hate to see grid development get delayed because of a porcelain insulator.
Yeah.
A pretty simple product.
Yep. Kaitlin, Pablo, you have any supply chain wisdom?
Maybe not directly, but I think the supply chain challenges highlight the advantages of taking an all of the above approach to tackling the grid bottlenecks, the grid challenges. You know, we work on a software technology. The issues are not there. It effectively provides time to then resolve the supply chain issues. And then, you know, likewise, expanding to, you know, dynamic libraries we mentioned before, and you know, many other technologies. I think diversifying not only on the supply chain for one specific technology, but taking the entire menu is very important. And you know, all of these approaches are complementary. So that's the other key thing to keep in mind. It's not like they are competing.
Yeah. We're going to segue now. Next topic is policy. What are the policy enablers that are going to help us get there? And I'll give you a few minutes to think about that while I sort of introduce one policy vector that it really impacts supply chain, and that's trade. You know, the USMCA agreement, our electrical grid is really a North American grid, and our supply chains are very, very well connected to US, Canada, and Mexico. So for instance, the electrical industry is highly integrated, much like the automotive industry. And so I think, you know, that agreement is in the process of being renegotiated. We've got a July deadline to establish intent for the three countries to come together, but that's an important signal around trade and supply that affects investment. It affects how companies are thinking about where to place manufacturing facilities, whether it's here or Mexico or Canada or elsewhere. So, you know, I think from an electrical industry standpoint, I think the current trade environment is really important. It's really important to get right so that we are, yes, incentivizing investment here in the United States, but also, you know, thinking about surgical approaches that don't hamper the need to build now and to build today, especially when there are certain grid-relevant components that are just not domestically available. So beyond trade and tariff policy, unless you all want to talk about that more, what other policy instruments or measures do you see as vital to accelerating speed to power? Kaitlin, you want to start?
Yeah, so permitting reform is a real top priority for Google. I'm not an expert in our federal permitting reform efforts, but we do have a white paper that's posted on our website that goes into a little bit more depth about our thinking around those sorts of issues. I think on the advanced transmission technology side, what we're actually seeing is it's legally permissible for us to be doing what we're hoping to do in sort of funding accelerated deployment of these technologies under existing statute. What we're not seeing is sort of that urgency to get things done quickly, and I think that's where signals are helpful, but really just, I think maybe more of a message is that there is this opportunity if we can unleash private capital to make these legally permissible sort of investments in the transmission system in a way that we haven't done in the past. All of the enormous benefits that would come along with it, but I think we sort of, to some extent, need some fresh ideas in that space, because we're seeing now some of these studies aren't necessarily resulting in immediate deployments. They're more sort of long lead time and you know, considering evaluation under existing process, but how do we sort of break the business as usual approach in a way that preserves reliability, but also pushes innovation that provides ratepayer savings in an era of rising electricity rates?
Yep, for sure. Pablo, Mike?
Yeah, I mean, The DPA, it was very great to see our industry addressed in the DPA. Now, the next step is, what's the tangible actions that will take place because you've been called out as a critical industry? So we're very anxious to see what will be the tangible critical actions that we can apply to our business to accelerate, whether it's innovation or investment. It's easy for us to make a decision to invest in the US. We've done that. We've got 14 factories in North America, 12 in the US. But if we can accelerate our R&D research to help develop some of these new technologies, certainly the DPA can probably present an opportunity to help the economics.
Yep, for sure. Yeah.
And I will echo Kaitlin's earlier point about transparency. I mentioned that our experience with Alliant and ITC in the middle of the country. We have been able to achieve those gains because the region is transparent, or has transparency in, specifically in the Mid-Continent ISO, also SPP and ORCOD. But it's not the same across the country. So some regions are less transparent than others in certain aspects. So having a directive or a mandate to be transparent would be very important. So fully echo Kaitlin's points.
Do you have a perspective on the linkages of the topic, sort of the entirety of the topic we were just talking about: supply chains, transparency, understanding where your materials come from, where your source, grid-related technologies have national security imperatives. So, how do you think about that in terms of supply chains, knowing your supplier, where especially digital connected technologies, where they're coming from? How do you think about that with regard to moving fast?
Yeah, super important to keep that in mind, and clearly you want to be transparent, but fully transparent with everybody. But there are certain players that should be able to see. When you have assets on the ground, we should be able to have full information, and then clearly for them to be fully responsible on the security implications.
Yeah. And even more important, to make some of those products, identify those products that should be made
exactly
here and with our allies.
Mm-hmm. Yeah.
Okay.
Well, I was curious if you have any thoughts, because I hear about this a lot, the foreign manufactured components and potentially some of the grid security risks that those present.
Yeah, I mean, well, Make It American program that NEMA has is certainly helping with some of the BABA requirements and ensuring that it's an even playing field for manufacturers. I would go back to the supply chain constraints in the COVID era. If we think about not our industry, but if you think about the pharmaceuticals, then you say, well, I don't really care if the pharmaceutical's made here or there. We had a logistics issue, and there was a real fear that we wouldn't be able to get the right pharmaceuticals because of the logistics issue. So even if you take national security out of it, there's something to be said in being in this hemisphere. And then the second part of the equation is it really is about knowing that this product came from this region and that you have the certainty of supply. Because one of the biggest, I would say, disruptions to the utility customer is if you do not deliver the product when you said you were going to deliver it. And so to be reliant on the logistics side is difficult. And then certainly on the electronics side, you want to ensure that it's manufactured here and doesn't have, some way of violating our own national defense.
Yep, for sure. Okay, we're about to wrap up, and I think to close, let's do sort of a rapid fire conclusion. If you could identify one thing that we could do now that would make a difference in delivering power with speed, accelerate progress, help us meet the need that we know is coming, what would that one thing be?
But I'm going to go. Because,
okay.
And Debra, you probably know this. I would say it's not one thing. However, I do think that we are seeing this heightened awareness of the criticality of the U.S. grid, and that's good. And we just need to make sure that there are tangible actions that are allowing the grid to be, I would say, upgraded with the existing infrastructure and new infrastructure much faster.
Yeah, I was going to say something similar. Opportunities and urgency sort of come to mind for me, and letting data centers serve as that catalyst for broader grid benefits, because what we're seeing is theoretical opportunities and sort of business as usual, and it's a recipe for a lot of stagnation that's holding us back.
I think that's happening. I do think that that's happening. You know, the fact that we're having this conversation, that it's bubbling up, I think you are the catalyst for much needed change and investment. Pablo, how about you?
Well, we have the technologies. Let's use them, as we were saying. Yeah, that's good.
Yeah. Okay. Thank you very much, Kaitlin, Michael, Pablo. Please join me in thanking the panel. Great insights, and we hope you enjoy the rest of your proceedings today.